to 6.4. This is the first of two videos. Yeah, it's very exciting. And what we're going to talk about today is we're going to talk about using inverse functions. And before we talk about using inverse function, it's probably a good idea to understand what an inverse function is. So we'll start there. And in order to understand inverse functions, we need to know a little bit about function composition. All right, and this is something that we did before. But if you have two functions, f and g here, and you want to compose f with g of 3, we can do it as follows. So first we'll find g of 3. G of 3 is just going to be 3 squared plus 3, which is 12. And so the idea is that we are now going to put the output of g of 3 into the input of f. So what we're going to do now is we're going to do f of 12. And that's going to be 4 times 12 minus 3, which is equal to 48 minus 3, which is 45. So that tells us that f of g of 3 is equal to 45. All right, so let's get a visual of what that actually means. So the idea is we have this little machine, a couple of them actually. We'll call the first machine G and the second machine F. And what this is really saying is that we're going to take the number 3, we're going to insert it into the G machine. And the G machine is going to perform some operations on it, and out is going to come a different number. And that number we saw was going to be 12. So G did some stuff to 3, changed its life, made it a 12. Now what we're going to do is we're going to take 12 and we're going to put it into our new function f here, our next function. F is going to do some magic here, some f magic onto 12, and out is going to come 45. And so what we have is we have a sequence of machines happening here. We have one machine acting on a number. The result is going to go into a new machine and come out into something else. And so this is what function composition really is. And function composition, like I said, has a lot to do with inverse functions, and we can learn a lot from composing inverse functions. So let's talk about what is an inverse function. All right, inverse function is what we call an undoing function. Many of our functions do things, all right, and they multiply numbers, they square numbers, they subtract numbers. But really what we're looking at here is an inverse function takes whatever a function does to a number and it undoes it. All right, a function that undoes the work of another function, does the opposite in the opposite order. And we write it like this. If you have some function f of x, then its inverse is written as f raised to the negative 1 of x. Okay, this is read f inverse of x. So let's first talk about this function, f of x equals 2x plus 3. What happens is we have this function f, which we'll give it a box, and we put things into the function. Okay, we put numbers in. All right, let's give an example number. Let's give 2 as a number. If we put 2 into that function, it's going to perform some work. What's going to happen is it's going to multiply that number by 2, and then it's going to subtract 3 from it. That's the machine's job. And out comes a 1. Okay, 2 times 2 is 4, minus 3 is 1. Now, what the inverse function is, okay, let's just write f inverse. The inverse function is supposed to, its job is supposed to take what came out of that function. If we put it into the function, we would like the inverse function to undo the work that this function did. So this function took a 2 and converted it to 1. So if I'm supposed to undo the work here, I'm going to take the 1, undo what was done to it, and bring it back to where we started at 2. That's the work of an inverse function. All right, it's basically undoing what you've just done. If you have a little brother or a little sister, and maybe you clean your room, your little brother goes into the room and basically just undoes everything you just did, makes the room all messy. So that's kind of what you think of an inverse function. Maybe not as annoying as a little sibling. So that's our goal here. We're supposed to find some function that undoes the work of another function. So to do that, we can list what's happening to the numbers being put into a function. So that's what we're going to do next. So if we have this function, f of x equals 2x minus 3, we're going to stay current with this function. What happens when you put a number into it? So for instance, if I put in like a 7, what's the first thing you're going to do when you put 7 into this function? You're going to multiply by 2. After you do the multiplying by 2, what are you going to do next? Well, 2 times 7, and then I'll probably subtract 3. So that would be our next step. We would subtract 3. Good old order of operations. So that's what this function does. If you were to describe this function in words, it would be, well, this function multiplies by 2, and then it subtracts 3. Now, the inverse function does the opposite in the opposite order. Okay, so it does the opposite of what this function does, and in the opposite order. So if we're going in the opposite order, we'll start here at the bottom. This function subtracted 3. The opposite of subtracting 3 is to add 3. Okay, now we'll go back to the first step here. This function multiplied by 2. We want to do the opposite of that. The opposite of that is to divide by 2. And so here we can write this function. F inverse of x takes a number x, okay, any number, and we just give it a variable so it could stand for any number. It adds 3 to it. After it adds 3, it takes the whole thing and divides by 2. So if we did this correctly, we would know that the inverse function is x plus 3 all divided by 2. And what it should do is if you put a number into the original function f of x, and whatever you get out, you put it into this function, it should end up at the exact same thing. Let's just check to make sure. Let's find we know what f of 2 is. We already did it. It was 1. So that means that f inverse of 1 hopefully is 2. Let's check it. So we put 1 in. Okay, we've got to do that 1 plus 3 first. So that equals 4 over 2, which equals 2. All right, perfect. So we put in 2, we got out 1. We put 1 into the inverse, and we got back to 2. Now, that does not prove that it's the inverse because that's only one number. To be an inverse, it has to work for every single number. So that's what we're going to do. We're going to go on to the next part. Now that we think we have an inverse, how can we check it? So we already did 1, but it says find several inputs of f of x and put the outputs into f prime of x to see if they match the desired inputs. We did that with one number, so we're not going to go in any further. But the idea is that if you take just any general number, x, and put it into f, you're going to get out f of x. Then if you take that and put it into f inverse, you want to get out what you started with. So if you start with x, you put it in, you get some new number, f of x. You put f of x back into the inverse, you should get out what you started with. And we started with x. And so what that tells us is that if you do f inverse of f of x, and that's what this is, that's putting in f of x into f inverse, hopefully it will equal x. I used g here. Can you change that for me? I meant to use f inverse for both of these. Sorry about that, but that should be f inverse. Or you could just say that this is g of x. But I meant to use f inverse there. So hopefully if we do this, we're supposed to get x. Well, let's do it for our previous example. If you remember our previous example, f of x was 2x minus 3, and f inverse of x was x plus 3 over 2. Let's see if it works. So if we put this function into the inverse, this is what it would look like. It would look like 2x minus 3 plus 3 over 2. Okay, that's me putting in this function into the inverse. So we can do a little simplifying now. 2x minus 3 plus 3, or the minus 3 and the plus 3 cancel out, so you have 2x over x. And if you divide by 2, you get x. So it worked. All right, we put x into the original function, then we put the result into the inverse, and we end up with only x. This is proving that they are inverses. This proves that f and f inverse are inverses. That is terrific. Okay, that's all for the first video here. There is another video that I'd like you to watch, so enjoy that, and I will see you soon.